So again, we'll take a look at now some of the operations, system design, and part of that is the efficiency of the systems. We'll briefly talk about maintenance and other conservation measures as well. So when you're designing a system, it's based on, we might boil it down to 4 main areas, okay? So one would be the climate, and really we don't have control over that. I mean, I don't know what this winter is going to look like in terms of the temperatures and how long the winter will be, but we're kind of dictated by that to a large extent. We can look at fuel, the price and availability, especially if you have a furnace or a boiler or something like that that can work with different fuels. You might want to look at what fuel is available to you. I know that I don't have natural gas. I can have propane delivered, but it really depends on where your home is and what type of fuel you have available and the price of that fuel as well. And we'll look at ways we can assess that. But we're really going to talk a lot right now about the efficiency ratings for all of the different types of systems, as well as proper sizing. And we don't want to make, if the system's too small, it's not going to meet our demand. You know, with a hot water, for instance, if it's too small, you're not going to have enough heat for your shower. If it's too big, it's not going to be as efficient. So we're going to look at some parameters there. You'll see on the right, I've included a couple common energy terms. For cooling systems, you'll typically see tonnage or tons of cooling capacity. There are some underlying basic science where these values come from. I won't get into that. But we'll talk about other units as well, BTUs, British thermal units. We'll talk about that and kilowatt hours. And there's some conversion charts there. As we look at some of these different parameters, we'll see these terms of BTU out, how much energy are we getting out. Each fuel source, you consider gasoline, natural gas, all of these have some energy content to them, and BTUs we typically measure. Electricity, like we talked about 2 weeks ago, electricity is measured in, energy is measured in kilowatt hours, okay? And so you can go back and forth between these units. I've highlighted some conversions there. If you're math-minded, you can consider some of those options as well. But we're going to look at some of the factors we can use to assess these sources. Now, efficiency, it's not just one parameter, okay? The efficiency ratings for heating and cooling systems are highly varied, okay? And so I'll highlight some of the prominent ones. There's the seasonal energy efficiency ratio, the coefficient of performance, the heat seasonal performance factor, and the annual fuel utilization efficiency. So a lot of different efficiency ratings out there. It can get quite confusing, but here's where it comes down to, and this references the question I asked a couple minutes ago. The energy guide label is required to be on all appliances, and what this label gives you is a number of different factors. It tells you all types of efficiency factors, including some of these we'll discuss here. It'll often tell you the expected financial savings based on that efficiency. And we did talk about some of these, the energy guide labels 2 weeks ago. So if you want, go back and review those recordings and you get more information on these labels, but we'll look at some of these. So on the left is the SEER, the seasonal energy efficiency ratio, could be very similar to the EER. And what this is, well, what I'll say about across the board, how these are calculated, and it can be a little bit more complicated than what I've shown here and what I'm sharing here. But for the most part, all of these efficiency ratings are calculated by the amount of energy that you get out of the system, which is heat, divided by how much energy goes in. Excuse me. So if you are working with the SEER system, for instance, this is for air conditioning units, it could be window units or central air conditioners. What you're doing is you're taking how much energy you get output from the system. Excuse me again. How much energy you get out from the system. And again, that's measured in BTUs because it's heat energy. And remember, air conditioners are just working in the opposite direction as a heater. And so you're just moving the heat from inside your home to outside. So it's the same concept. You're talking about cooling output in BTUs divided by the electrical input. In the case of SEER, looks at electricity input. So if you're looking at a oil or a natural gas boiler or something like that, you're not going to be using the SEER. You're not going to see an SEER with a boiler, for instance. This is only for electrical input, and so that's watt hours, not kilowatt hours, watt hours. You just make a note of that. But in any sense, you can see I've just included some average values for each of these. For a room air conditioner, is typically above 8, and the requirements, federal requirements, are always being boosted to make these systems more and more efficient. And so you're not going to find, unless you already have one of those older systems, you'll typically find them above those levels, or they need to be above those levels to be sold on the market today. The ground source heat pumps and air source heat pumps, that's abbreviated GSHP, ASHP. So those heat pumps are a bit higher SEER ratio. So again, that's one indication that the heat pumps are far more efficient than your central heating and cooling systems. And these are just standard values. I can't say that it's across the board. Every system is within those ranges, but that's that's out there. Coefficient of performance, you're not going to see that as much unless you're more of an engineer. You don't see these as often, but they do pop up from time to time. Actually, the figure there might be, the figure I have for coefficient of performance actually is outdated. And you're really not going to see, to my knowledge, you're not going to see the coefficient of performance listed on an energy guide. So that's one that you're not going to see listed. I just failed to update that information. But that works the same way. It's the output capacity over the electricity. Same thing with HSPF, the heat seasonal performance factor. It's heat generated divided by electricity. And then the AFUE is you know, that one's different. It works with those sources using fuel. So if you have a natural gas burning boiler, you'd get the heat coming out of the system divided by the fuel of the natural gas in that case. And this is the only one that's given as a percent. In any case, when you're comparing two systems, and like I've done in the figures at the bottom of this presentation, you can compare two systems and see which one has a higher efficiency. It just depends on what type of system you're looking at and what efficiency parameter you're given. So with the water heating systems, the older ratings work on an energy factor EF if you have an older system. The newer systems are working with uniform energy factor, UEF. And it gives you a bit of information there. It gives you, it's a little bit confusing because even on the new tags, a lot of the new tags are saying energy factor. This example that I've expanded and made bigger there, it says energy factor of 3.39. I believe that is the new standard, the uniform energy factor, but it really doesn't specify that, and it wouldn't make sense for that to be the old version of that because those are decimal values. But in a sense, you're with water heaters, that's what the efficiency ratings for these are. The older systems, EF, the newer systems have that UEF value. And when you're comparing those systems, there's 4 categories. Okay, when you're looking at a water heater, it's either a very small, a low, medium, or high system. And so the parameters are shared there in terms of the first tank hour rating. That kind of is based on the UEF, but it's in one of those categories. So you have 4 categories of water heaters to select from, and you cannot compare across categories. If you have 2 water heaters that you're considering, they have to be in the same category in order for you to compare those together. So that's the water heater side, and we'll talk about some of the sizing. If you are looking at just a quick rule of thumb, and I don't advise doing this with systems, just kind of buying a system just on the number of people, but just for a ballpark, depending on the house size, you're obviously going to need a bigger water heater. Okay, and so that's what I've included there up in the red or pink chart there. The more people you have, the bigger capacity water heater you're going to have. And so you can find different resources. You can reference the manufacturer that you're considering, and you can see what they recommend. For actually sizing it, can be a little bit more involved. There's one option here, and I'm not going to get into it in detail for brevity's sake today, but there are some formulas where you can that are based on that uniform energy factor. And so you can multiply your uniform energy factor, UEF, by how much energy you need. And so this is often based on heating and cooling loads for systems and for your hot water demand. Okay, and so this is often all based on the what's known as the peak hour demand. Okay, and so that's the minimum amount of hot water that you would need in a 1 hour period. Okay, so I'm not going to get too much into this, but for most of us, you're kind of looking at the ballpark. I have, you know, a family of 3 to 4. Then you're looking in that for electric systems, 80-gallon systems. If you want to get more involved in it, and I can help you explore some options there, that information is listed. For Maryland, we're in that light blue region, which is 566 BTUs per gallon. And so the climate that we're in here in Maryland really dictates some of that calculation. If you're to go in and calculate a little bit more robustly what size water heater you would need. So again, I'm not going to get into the details there. Sizing for air conditioners. Again, we already talked about the top one, SEER, the seasonal energy efficiency ratio. Remember, it's the output over the BTUs divided by watt hours of electricity. The sensible heat ratio is important as well, and that's because you're also dealing with moisture in the air. Okay, so if you have a really wet, moist environment inside of your home, your tendency is to turn the air conditioner down even colder to make yourself more comfortable. The problem is you're really not dealing with that humidity issue, and you're wasting a tremendous amount of energy by turning the temperature lower and lower in the summer just to try to get rid of that moisture. Now, air conditioners don't control the moisture directly, it's rather indirectly. But when you're working with a contractor or an installer looking at different air conditioning systems, cooling systems, they're going to need to look at both from an SEER standpoint and an SHR standpoint. So it's temperature and moisture standpoint, and make sure that you're kind of balancing those. And you also know the tonnage as well. Be aware of that. And again, you can take tons and convert that to BTUs and vice versa if you're more comfortable in one system than another, or if one system is marketed in one way and another is marketed in a different way. But what I do recommend is when you're properly sizing the system is to work with a contractor to do a load calculation. They're going to look at heating, cooling, and moisture impacts and determine proper sizing for your system. Maintenance, and I'll just quickly touch on these. I recommend servicing all of these types of systems annually. There are some cleaning and work that you can do yourself, but a lot of it will have to be contracted out, and you can usually have a tune-up for fairly cheap. The air filters are things that you can replace yourself. Check those regularly, whether it be your furnace or air conditioner or other system. Typically, you're going to replace those once a month or every 3 months, depending on how heavy that seasonal use is. Safety is a big issue as well. Anything that has a flame, it can build carbon monoxide, so you have to check if you have ventilation. Make sure that, and we could spend a week just talking about some of these safety issues and other maintenance issues, but you don't want to have furniture up against your heating systems. It could catch fire, all those kind of things. And we'll talk a little about ductwork and pipes as well. You want to make sure those are insulated and sealed. That's something that actually come up more in 2 weeks, our session on weatherization that's coming up. But you have a lot of losses. I'm not going to get into detail because I said we'll revisit this topic in 2 weeks. But you can have, through those distribution systems, with a central system in particular, you can have a lot of leaking air and other things could account for a tremendous amount of energy loss. And so whether you're comfortable working with some of these systems or you hire someone out to check these systems, you need to make sure that it's all sealed up. You can use mastic tape, and I don't recommend duct tape on any flumes or anything, or any ducts. It's best to use insulation and tape that's made for that function. There's aerosols as well that can work in hard to get spaces. I don't have any experience with aerosols, but the duct tape is not great. Mastic tape works pretty well, and it's recommended. But that's something to keep your eye out on. Now, a couple minutes left, and I'll just briefly touch on this. Some of the things we talked about previously in our previous session. But one thing I'll say is any cooling or heating that you can do without these systems is going to save you money. And so it's recommended that you use a fan. And of course, a fan works in the summer. It'll chill anyone in the room. But in winter, again, you can, on most units, you can flip a switch on your ceiling fan and it will circulate and mix the hot air a bit lower. So that's something to keep in mind. You want to make sure it's positioned in the room right. If you're installing a new fan in a room, you can check some of the distance and height. You don't want to have it flush with the ceiling. I've seen that in basements. If you have it flush against the ceiling, it's not going to circulate as well. You want to have about 8 inches, I believe, or 18 inches. But there's information out there on some of that, and I've shared some resources here where you can get some more information on that. If you have questions on it as well, I'd answer those. Thermostats can also save a lot of money. Again, this is conservation, just a behavioral change. And so a lot of different thermostats out there. I mentioned this last time, but a lot of people have programmable thermostats, but I think only the latest fact I heard was 12% of people are actually programming those thermostats. Okay, and so what a programmable thermostat does is you can set different periods of the day where if you're not home all day, you can adjust the temperature. And so that's what I've included to the picture off to the right-hand side. When you're at home in the winter, 68 degrees might seem a little cold to people, but if you're comfortable with it, bump the temperature a little bit lower than you're comfortable with, and you can save quite a bit from that. When you're or at home at 68 degrees, when you leave the home, you could bump it even lower to 60 degrees and asleep 65 degrees. And so making some changes like that can be pretty helpful, can save quite a bit. There's some estimates on savings there. For a baseline charge of $1,500, you could save upwards of over $200 just by some temperature changes. So that's good recommendations as well. With hot water, you want to use less hot water, so take quicker showers. You might have an aerator or a low flow shower head to save additional hot water. You don't want to run more hot water than you need to. More cold water, so run all of your dishwasher cycles on cold if possible, as well as your washing machine for your clothes. There's also some technologies out there, drain water heat recovery, HRUs, gray water recovery, whatever you want to call it. And typically that'll be extended into the basement because you need about 2 or 3 feet below your shower basin to collect the heat from that runoff water. And so the water that goes through your shower and down the drain, it's already heated up and you can recapture some of that heat. So that's an option out there as well.